Thank you all for coming out this afternoon. Welcome to SEC302, how LogMeIn automates governance and empowers developers at scale. My name is Cameron Worrell, and I'm a solutions architect with AWS. And I'm joined today by Brian Galora, who's a principal technical operations architect with LogMeIn. And today, our goal is to really help you understand and talk about some concepts that will enable you to help you be successful as you look to empower your builders and your developers operating on AWS inside your organizations, but also maintain governance and a degree of guardrails around those actions and the things that are going on in your environments. And so as we go through our talk today, we're going to start off with some sort of foundational elements, so some core building blocks. We're going to talk about just some basics around that, and then we're going to move into some of the primitives and patterns that we see. I'm going to hand it off to Brian, who's going to dive deeper into the LogMeIn tooling and governance approach. And then we're going to do a demo for you as well. And then hopefully we're going to give you some takeaway things that you can go and sort of look to build out this type of practice within your own environments that you run. I would ask if you could please just hold questions till the end. Brian and I will be available. If you want to just come up or ask us questions at the end, we'll be available for that. So things that, again, that we'd love for you to come away with this with. So of course, removing that friction, so really enabling builders to go do what they need to do, but also, again, providing the guardrails and the governance around that. Reducing cycles, reducing overhead. So, our automation can be very powerful for helping free up cycles, helping your teams actually focus on higher priority, maybe more strategic things that are on your backlog. When you automate, you also increase visibility. So, taking away that you can really get higher degrees of fidelity in your logging, better visibility into what's happening, which is a good thing as well, of course. And then also this sort of notion of shifting left on security. So you've heard this. This is kind of putting the controls closer and earlier into your development life cycle. So you have those controls happening at an earlier time in the development process. Also a very good thing to go do. All right, so again, if you think about the AWS platform, we're now at 140 plus services, and we have very large array of capabilities, and you have demand for those capabilities. So across your teams, across your builders that are out there, they're looking to take advantage of this. And so what you are, of course, looking to do is really take the business opportunity when you have an opportunity in front of you to come up with an innovative idea or a new project, meet that opportunity with your builders and give them the tooling that they need and the access that they need to do that. These aren't just builders and developers. This might apply to other constituents in your organizations like the security teams. You have folks in finance and operations as well. Just out of curiosity, how many of you have 20 or more developers within your organization? Okay, how about 50 or more? Okay, 100? Cool. Well, so it's not just about how many builders and developers you have. It also becomes about the complexity and the types of things that they're interacting with. But what you are looking for is to foster that innovation through the life cycle. So as you go through the ideation process, prototyping, sandboxing new ideas, giving those developers and builders the access they need to go do these things. And then as you move closer, you move closer to production, some things work out and you want to move that through a code promotion process closer to production. You're going to build a life cycle around making that happen. And so as you kind of iterate through this process, those controls are going to change and you'll evolve that. And typically you see guardrails evolving, but you want to have those guardrails probably shrinking a little bit, maybe adapting to meet each stage of this life cycle. And then finally, as you get kind of more into the production operations, you probably have much more control wrapped around that as you go through it. And that's really what it's about, is fostering this while having the controls in place. We'll talk more about this as well as we go through our presentation today. So what is IT governance? So I don't want to go down a rabbit hole on defining this, because it's a very broad term. It can be taken a lot of different ways, but if you think about what I mentioned before, which is helping your business achieve the goals, and that's the key, right? But beyond that, you have to be effective and efficient at accomplishing the achieving of those goals. So that means that you've applied, a security process, you have least privilege, you've got due diligence happening, you're taking prudent steps to make sure that you're effective and efficient. And it may be also around cost controls and things like that as well. So the platform itself is broad, but the access methods are also broad. And it's very, most developers have their own tool sets that they prefer to use. And builders, some may like to use more direct tooling that's native SDK-based stuff. Others might use frameworks and different types of tools that are out there. So the idea is that you can really, by building guardrails and not gates, you can kind of foster this environment where you can have tooling that the folks prefer to use. They can go in, take advantage of native SDKs or their preferred toolkit, CloudFormation, partner in ecosystem tools as well, and still maintain those guardrails. Another aspect to think about in terms of, you have to automate this stuff, you have to represent these things as code, but you also still want to have some sort of awareness happening. So that would mean that you want to build a documentation set, or make sure that you have communicated out to your builders, here's the policies, here's how we expect you to interact with the services, and we're going to remove the friction, but kind of here's the guidelines that you should be following. Brian's going to get more into that in a few minutes. All right, so that kind of sets a little bit of the foundation. The next thing I want to do is dive a little bit deeper into sort of the boundaries and a little bit more on the technical side of things. So how many of you are using AWS organizations? Okay, so organizations, I see quite a few hands going up. So you should be using multiple accounts. The account is the core boundary of how you can isolate privileges and isolate principals from an IAM standpoint, and also control blast radius. So you're absolutely right to be doing that, and you probably have something similar to this, where you have, it might be by environment, you have OUs laid out, it could be by region, it could be by business unit, or all of the above. But what we're going to talk a little bit more about today is, let's zoom in on one of these accounts in an organization. And so you still need to scope down those permission sets, and you still need to scope down that access within those accounts. So invariably, you're going to have accounts, and within an account, you're going to have multiple teams or tenants that need to consume resources. The idea is that you kind of separate the actions that they're taking and prevent them from doing things that would potentially be harmful. And so things you'll be doing there is looking at kind of the core components. If you've got resources, you should be following a tagging policy to make sure you're tagging those resources. IAM policies that are behind that to govern the access within it. We'll get in there. We'll get into that in a moment, a little deeper. And then the roles. So working through roles. If you can do federation, that's a recommended approach. So you can federate into your preferred identity provider or whatever you're using, and let those constituents, the builders and so forth, come in through that mechanism. So a couple of just kind of policy primer here around identity and access management. So if you look at the left side, you'll see kind of a standard policy. So as most of you likely know, IAM gives you the ability to have fine-grained access controls around your resources in AWS. And so this example on the left, we have just the basic JSON structure that you're going to be working with. So I'd just like to highlight the PARK, the PARK aspect of this. So principal, action, resource, and then constraint. And so you're going to be working with this policy and then leveraging the mechanisms that are represented there on the right-hand side to be able to dial in access and put the permissioning around those folks that are coming in as appropriate. So by default, if you don't have access to something, there will be an implicit deny. So you will be essentially not allowed to commit a specific action. You can also use an explicit deny, so you can override other policies with that. You can use resource level permissions, and then you can also use authorization based on tags, and we're going to talk a little bit more about that. And then resource policies, and finally permissions boundaries. So there's quite a few things that you can do here to kind of manage the policies at scale and use these in a way that allows you to build those guardrails that I mentioned. All right, let's look at a couple of examples now. So the first example on the left is kind of a tenant separation example. So this is preventing teams from sort of stepping on each other. In this case, we're using an IAM condition. That condition is basically based on a tag on that resource that indicates the team is dev1. So this is a way that you can prevent teams, or groups from actually taking actions against resources that belong to each other. You can also use this approach with the prevention of high blast radius. So the approach on the right is actually an explicit deny. So that's where we want to prevent high blast radius type things that you would really just want to have a type of proxy in place or some sort of brokered action to prevent things like modifying security groups, spinning up new security groups, internet gateways, elastic IPs, and things like that. Now, these are things that your developers and builders may indeed need to do, but you typically want to have some additional controls around how they go take those actions. So once you build out your kind of that baseline that we were looking at a minute ago, and you have your policies in place, you've got the principles coming in, you're going to have kind of a life cycle around that. So this isn't really a set it and forget it type of thing where you finish your policies and you're like, okay, I'm done, let's move to the next project. You really need to have a life cycle or a feedback loop in place to be able to iterate on that over time, because teams are changing, projects are changing, requirements are changing, and you need to adapt your policies along with that. So in this chart, in this kind of flywheel here, you'll see that we start with kind of we're operating and collecting information about how resources are being accessed and consumed. We're analyzing that information, placing that back into our policy framework, and then the process goes on. And so Brian's going to talk a little bit more about this, but it's good to think about this as you move into managing your policies at scale. All right, so I talked a little bit about this, but there's a couple of extremes in terms of how things can be accessed, right? You could have everything from, a star policy that where your builders have free reign and they can just go in, or you could have something where there's zero capability and they're just checking in code and everything is abstracted. You don't necessarily want either one of those. You may want something in between, but that's going to vary based on your requirements. The idea here is, though, you do want to have least privilege enforcement. You want to follow that type of approach, and you want to broker sensitive actions. So when you're brokering things like high blast radius types of actions, like potentially provisioning security groups or internet gateways, things like that, there may be legitimate reasons for someone to do that, but you may want to have some sort of broker or proxy in place where you can pass that request through, do some governance checks on it, and then if it meets that, it's within your guardrails, go ahead and provision it. And we'll take a look at that in a minute. All right, so the example around that, if you think about that brokering pattern, so in this case, we'll talk a little bit about CloudFormation custom resources. So how many of you are currently using CloudFormation or CloudFormation at all, I guess? Okay, how about CloudFormation custom resources? Okay, so a couple of hands. So CloudFormation Custom Resources, it gives you the ability to put your own logic and create resources within CloudFormation, and then within that logic, you can build various elements that you want. In this case, we're using those to do governance checks and make sure things are within guardrails before they are provisioned. So in the example here, you see that you've got a builder. They're going to use a CloudFormation template, submit that. Within that template, there's a custom resource. And then in the example, you will have potentially several different lambdas with different custom resources. The top one would do an IAM policy validation. So in this example, they would submit the custom resource. The IAM policy would be validated by that custom logic and the lambda backing the CloudFormation custom resource. If it meets the criteria and it's within those guardrails that we've defined, it's going to go ahead and provision that. If it doesn't, it's going to kick it back. The builder or the developer is going to get some feedback about, hopefully some logging data about why that didn't make it through, and then they could resubmit it. But the idea here, again, is that you're automating this so that the majority of the things going through can be handled without a human. You want the humans, ideally, to look at the exceptions and not all of the activity happening. There's a couple of other examples in this where you might have a security group lookup so that security groups don't have to be provisioned each time. They can pull from existing ones that are already out there. And then a subnet lookup as well, or a subnet assignment. So these are all examples of custom resources with CloudFormation. You can extend this in ways that make sense for your own use cases as well, of course. All right, a couple of other tools to mention. So IAM Policy Simulator. IAM Policy Simulator is essentially, you can use the console or the API. Hopefully you're automating these checks, and if you're using the API, essentially it gives you the effective permissions on a principal or role that you can check to see what actions that role or principal can take. So that's a very valuable service that you can use for automating governance checks as well. Zelkova, we're gonna talk a little bit more about. This is a service that uses basically automated reasoning to essentially mathematically prove the permissiveness of a policy. So we'll talk a little bit more about Zelkova in a moment. And then there's a large ecosystem. So you may have your own custom tools that you've built. There's tools that are out there from Netflix, RepoKid, Aardvark. You may have heard of some of these. CFN-NAG is another interesting one. It's by Stelligent, and it can actually interrogate CloudFormation templates for security types of checks. And then Cloud Custodian by Cap1 is another example. All right, so a little more on Zelkova. So essentially, I mentioned this is basically leverages automated reasoning. And what it's able to do is mathematically prove the permissiveness of a policy in the example we'll talk about. So you essentially will send Zelkova a probe policy, and it will compare that to the policy that's being requested. And you use that probe policy to essentially set your guardrails. It's all about these guardrails, right? And then it can actually determine, is that policy that's being requested more or less permissive than your guardrails? So this is, again, back to this automation theme and avoiding having to have humans go in and do these things. Zelkova actually backs other services, so the S3 bucket checks that are out there, things like Trusted Advisor, Macy, and config rules as well. These services take advantage of Zelkova underneath. So at this point, I think I'm going to go ahead and turn it over to Brian, and Brian's going to come up and dive deeper into the LogMeIn governance automation.
Thanks, Cameron. When I first started working on governance problems at LogMeIn, I had this vague idea that it meant I needed to generate reports and make access policies. And after I started to understand the domain a bit better and dig in a bit more, I saw that there was lots of room for innovation. And I got really excited to apply some of the tools and primitives that Cameron just talked about. So let me start by telling you a little bit about LogMeIn. We're a top 10 global SaaS company. Our worldwide operations today include over 3,500 employees in more than 20 global offices. These offices, our products support 4 million daily users, 24 million free users. We have 2 million customers and 6 billion annual interactions. In the title of the talk, we mentioned scale, right? So I think it helps put that in perspective. The company's well-known products are used by millions of people worldwide and include the likes of GoToMeeting, Join.me, LastPass, Bold360 AI, and more. At this point, we've been using AWS for production workloads for about 5 years now. And today I'm going to focus on a little slice of this world and how we leverage AWS to automate some of the governance processes. So this is my interpretation of the definition of governance. Cameron touched on the Gartner definition a bit earlier, which is a good industry-centric definition, but I wanted to come back and drill down a bit to the LogMeIn interpretation just to set the stage for the next 30 minutes or so. The key things to consider here are appropriate and auditable. I'll try to break this down from a high-level definition to an understanding of stakeholder needs, and then some practical examples of how we address this at LogMeIn. And yes, I'll do a little demo. So let's talk about stakeholder needs. Different constituencies have different concerns with respect to governance. And just to get you thinking in the governance mindset, here's a few examples of some of those. Some of you in the room probably fit into one or more of these categories. Developers are consumers of resources, so it's a balance to always give guardrails and preventative controls without inhibiting their work. Operations staff have many concerns, but one of them is resource exhaustion, including watching quotas, which would break things across multiple tenants. Of course, with an unlimited budget, we could all get lots of things done, but finance serves as the governor on the AWS bill, so we need to pay them the appropriate attention. Security has a vested interest in ensuring sane preventative and detective controls for access. For example, who did this action, or who could do this action? Those are very useful questions to answer in many contexts. And business needs are effectively the net needs of all of your constituents, so it's naturally a moving target. And a healthy governance must adapt along with the rest of the business. Remember, policy is a verb, not a noun. So anything you implement has to be changeable. None of these processes are meant to be set in stone. So here's a high-level overview of what I'm going to be covering today. The governance is a really broad area, so I'll try not to bore you with some of the more mundane things. I will share the one thing that has given us the most value over the last year and a few greatest hits, things that we think we did right and have proved to continue being valuable over multiple years. We use CloudFormation custom resources in different places to great effect, so I'll talk about that quite a bit. It just so happens that CloudFormation is kind of the right place to insert governance checks in most of our workflows, but a lot of these checks and things can be inserted in any kind of workflow you have, whether that's branch promotion or any other kind of automation that you guys use. We also use an AWS service called Zelkova, which Cameron introduced. It helps us achieve something close to least privilege in our IAM policies, which is really hard. Zelkova can help you get to that next level of confidence in your security when the Access Advisor and related tools just aren't cutting it for you. And on the detective side of things, there's no surprises really. We leverage AWS config to monitor a number of things. And we have some CloudWatch alerts that fire on IAM changes when they aren't following our governance rules. After a short demo, I'll talk about cost, CloudTrail logs, and detective controls. So, how do you wrap your head around satisfying all these constituencies while effectively shooting at a moving target? Let's go into a little bit more detail about LogMeIn's governance processes around these specific resources. This is a 300-level talk, so I'm going to get a bit technical while we boil the ocean. So let's start with security groups. This is one of the simpler processes for us. We had a very different situation when AWS was new to us. As we scaled up, we had to manage risk and costs, and we had to adapt a lot of the things that we did. We used to trust people to make their own security groups and use them responsibly, but that didn't work out so well. So it turns out people really like to expose things to the internet that shouldn't be. So we implemented a fairly strict process around reviewing and creating security groups. The migration process was painful, as you can imagine, but we are now in a happy place. In the future, I'd like to improve our detective controls around this with an AWS service similar to Zelkova called Tiros. Tiros would allow us to remove much of the human work involved in reviewing security groups. Tiros lets you determine network connectivity between contexts without sending any packets on the wire. It's a very powerful idea. Right now, the reachability assessment available in Spectre will tell you which instances are available from the internet, and I'm looking forward to the team expanding that capability. So our process for managing security groups now leverages some automation, but it's not particularly sophisticated because we still rely on humans to do a lot of the reviewing and deployment. A small group of users has access to deploy changes via CloudFormation, and this automation has the advantage of ensuring that groups are named consistently across every VPC and account. Because that naming convention is consistent, our developers can refer to security groups by name, and developers can leverage our Lambda-backed custom resource. This adds a layer of abstraction to security groups, but it doesn't slow our developers down, which ticks a couple of boxes for us. It's tricky to strike the balance between direct and brokered access. For many of our processes like this, we do the brokering through a custom resource. One of the reasons this works for us is that largely all the deployments in these accounts are done by CloudFormation, so this was the right layer for us to interface with. So far, this has proved to be very successful for us. So moving on to IP addresses. Running out of IP addresses in subnets was a frequent complaint from users. One of them is right here. Initially, this was curious because we had already provisioned additional subnets with more space in anticipation of this. Upon further investigation, we discovered that given no alternative, developers were hard-coding subnets right into resources or maintaining static maps. Having to update templates as we added capacity was clearly not scalable. It's also not a good experience for the developers. Adding capacity to the infrastructure should be transparent to the people writing the templates, so we needed to provide something better. So I'm oversimplifying a bit, but there are broadly two classes of subnets, public and private. You guys probably already know the difference, but just in case, private subnets use a NAT gateway to get out to the internet and cannot receive incoming connections. Public subnets need an EIP to get out and can receive connections on that elastic IP. And different applications have different connectivity and availability requirements. And with this automation, developers can select the appropriate subnet based on name instead of an ID, just like the pattern we used for security groups. With this brokered approach, we are also able to direct deployments to the appropriate least utilized subnets, regardless of the SDLC stage or the region they are in. This results in a sort of load balancing where fewer IP addresses are wasted. The CloudFormation custom resource directs the deployment to the least utilized subnets, so we get a more even distribution of usage of IP addresses. This also mitigates things like build systems or CI/CD deployments, hogging all the IPs during some large deployment and breaking other deployments. So moving on to IAM, this is the most complex resource we've talked about so far. Requests for changes to IAM policies used to be reviewed by people and approved, often without a clear understanding of the impact. Now we have a clearer understanding of what we want to protect with IAM and the automated tools to check those requirements. Not only did this improve the turnaround time for a typical IAM request from several days to a couple of hours for the most complex cases, the overall man-hours spent on this process were drastically reduced. This is opening up my time to spend on further automation. We're talking about dozens of hours a week spent manually reviewing JSON IAM policies and trying to determine what the blast radius of them were, and then manually deploying and going back and forth with the development teams to determine whether or not it actually met their needs, right? It's a big win for us. So infrastructure such as subnets and VPCs are a tenant that needs special protection. Really what we're trying to do is get as close to least privilege as possible. As I described, we used to do that manually. It was slow and potentially very error-prone. So now the tools, which I will show you in the demo, help us automate the analysis of proposed IAM policies and even provide a self-service way for people to be able to create policies within our governance constraints, completely removing the manual process from the equation. And believe it or not, this actually results in better confidence in our security, not only because of least privilege, but also because the standards are the same in dev versus production, and that CloudFormation template that contains the IAM policy that's proposed by the development team becomes an application artifact that's maintained from earlier on in the development process. It reduces the burden on operations and security functions and increases the speed of our development process at the same time. Now, it's important to understand that this solution isn't magic. It's probably not possible to get truly granular least privilege with this method, but for putting up some guardrails to enforce common sense tenant separation techniques in your most used AWS services, it can really increase your security posture. You can also look at it as a sort of test-driven IAM policy writing process, where the Zelkova probes are the tests, and your developers have to write their IAM policies in a way that makes all the tests green. And you can iterate as your governance needs evolve, and you can increase the number of tests as appropriate. So, as I was describing, we've had a lot of success recently enabling self-service creation of IAM policies for service or machine accounts. So that's any account not intended to be used by a human. But before I talk about that, let me talk briefly about IAM access for humans. We use federated login via SAML to our corporate Active Directory. I just want to emphasize that a bit. If any of you aren't using federated login, I think you should be, certainly at any kind of scale. Our users love it. They don't have to keep track of yet another password. Our admins love it because they don't have to track password age or two-factor status across hundreds of users and dozens of accounts. And it makes auditing easier for our security team to boot. So federated login, exclamation mark. One issue that comes up with federation is that human users need API keys. So we built some command line tools to wrap our federated login flow with a headless browser and populate the CLI config with temporary API keys from STS. We've gotten some great feedback from our developers on this, and it completely mitigates people from putting their personal API keys into automated jobs, and key rotation is no longer an issue. It's one of those rare situations where our users are happy and we increased our security posture at the same time. All right, back to security, to service accounts. My first tactic was to initially implement a simple JavaScript page backed by Lambda through Cognito to check policies using the Policy Simulator API. Basically, brute force trying every single possible IAM action with the proposed policy and checking that the outcome was in line with our governance expectations. After some initial testing with our provisioning team that fields access requests, I adapted the Lambda function to work as a custom resource also. So we had the same rules being enforced whether users came in through a manual process or they used a self-service custom resource. This was a huge improvement, but the Lambda function was really slow. It takes some time to iterate through all of these possible actions. I think there's 5,000 some possible actions in IAM. And it could only tell us we were safe in the areas that we thought to test, so we could still end up with some blind spots. This is exactly what Zelkova can help with. Because IAM is such a tricky area, I want to expand on the problem space a bit and talk about how we arrived at the Zelkova solution, and I'll get into a short demo. So even for subject matter experts, policy writing is really hard. Principals can have multiple policies applied: inline, managed, AWS managed, and then multiples of those. And now we've just added permissions boundaries as well to further make the issue further complex. And determining the net result of these things manually is really hard. Small, seemingly innocuous changes to these policies can have wide-ranging effects. And because of this complexity, you can end up in a situation where you did everything right? SME reviewed and approved an IAM change, it was deployed, and despite all this process, some resources could be compromised. So how can Zelkova help with this? Zelkova is an automated reasoning tool. It mathematically proves that your proposed policy is or is not following your governance rules that you've encoded into probe policies, hence the term provable security. This is in contrast to the policy simulator, which is more like plugging values into an existing equation. It doesn't necessarily give you the whole picture. I'll show you what this looks like in the demo. So one question that came up when we were considering our options for this problem was, can we use IAM permissions boundaries? And potentially it could solve part of the problem. Boundaries are helpful by broadly restricting some high blast radius items or protecting specific infrastructure resources, but it's not really appropriate for protecting cross-tenant access within a single account where there are many tenants. There are probably some ways to implement that, but it's just not the direction we went, and I believe the Zelkova solution is superior for our use case. There are also other limitations. Boundaries are only evaluated at runtime, which further obfuscates the net result of your policies. Zelkova can be placed earlier in the process, at deployment, completely preventing things from getting into IAM that you don't want to be there. So there's no window of opportunity for a compromise. So let me kick off the demo, and I'll come back and talk you through it. It takes a couple of minutes for the deployment to run. So in this demo, I want to show you what it looks like when a developer needs to request a role through the self-service process and deploy an application using the custom resources that I talked about. This workflow would allow you to create a CloudFormation template for your application resources and a separate one for your IAM resources, following the recommendations from the AWS well-architected framework. The stack for the IAM resources will create an IAM policy through a custom resources that checks it before it deploys, and an instance role. It would look very similar if you needed an execution role for Lambda or a deployment user to be used by a CI/CD pipeline. The stack for the application tier includes custom resources for VPC, subnet, security group, and IAM selection. So let's have a look. So if I'm a developer and I want to create an IAM policy, I've composed this IAM policy here, and I've been provided a web interface to check my proposed policy through. This is really a no-frills web app, as you can see, but what it's doing is calling a Lambda function through Cognito that checks the proposed policy against a set of governance rules. You can see the status of those checks in the modal pop up here. True is good and false is bad. It looks like my policy is failing some checks, but thankfully I can find the details of these checks so we can try to resolve this. So in this example, it's kind of small, but we're doing a number of different checks. This is just output from a Lambda function I effectively put into a modal pop-up. But the first one that's failing there is tenant tag generic. It's marked as false. So let's look at the probe policy for that. So this is the probe policy. It looks kind of like an IAM policy, but it's not exactly. It uses some of the same syntax. So in here we can see this probe policy. What I'm trying to do in this probe policy is to enforce tag-based conditions on certain actions, right? So in this case, we want to enforce restricting EC2 terminate instances to using a condition. And I can see here in my proposed policy that I'm trying to use EC2 terminate instances without any restrictions. So I think if I add a condition to this policy, it should pass our governance checks. I'll create a different tenant name so we don't collide with the probe policy. And there we can see all the checks are passing now. So at this point, I can request that this role be created by our provisioning team by opening a ticket. The policy will get submitted to our provisioning team, and they'll manually paste it back into this same interface just to double check it's passing all of the governance requests, and they'll go create it on my behalf. But being the enterprising self-service developer that I am, I can use the CloudFormation custom resource to create it for myself. So let's see what that looks like. This is the CloudFormation custom resource that we're using to create an IAM policy. I don't know how many of you are familiar with this syntax. We're looking at a YAML CloudFormation template. One of the first things here is just an ARN of a Lambda function that's backing this custom resource. And here's a policy that we want to create, just passed as a parameter to that Lambda function. Here we're creating an instance profile and a server instance role and attaching the policy. That's straightforward enough. So let's look at the application resources that are being deployed here. You can see we're specifying VPC by name, so we can look up the ID, subnet type, so we can look up the ID, same with security groups. The values that are returned by that are the IDs of the corresponding resources. Here we have a separate custom resource we use to look up the AMI ID of the latest Amazon Linux AMI in that region. That's covered by an AWS blog post I have on the resources section. And here we're creating a single EC2 instance, and we're passing in the outputs of all those custom resources, right? So at no point here that I have to look up any AMI IDs, subnet IDs, VPC IDs, anything like that. And last of all, we're attaching the instance profile we created in the other stack. So if we go back to our deployment, we can see both of those stacks were deployed successfully, and the EC2 instance was launched using the instance profile we created through our self-service process. So behind the scenes here, that CloudFormation custom resource is also creating a ticket in our change tracking system. So we have auditable evidence of who created that and that it was approved by our governance checks. Right, so that solved a lot of problems for us. Okay, so the other side of the governance coin, so to speak, is detective controls. We have a number of AWS config rules set up, which we deploy to our dozens of accounts using stack sets. We also use stack sets to set up common IAM rules for federated login and consolidated CloudTrail. Guard duty also provides many useful security alerts, often for things that we didn't think to look for. So moving on from detective and preventative controls to auditing and reporting. This is important because we need to have a facility to manually investigate configuration changes and other events. And in our environment, all CloudTrails logs are aggregated to a central account that is secured for all of our dozens of accounts. And access to this account is strictly limited, so we wanted to find a way to delegate access to this without giving direct access to that account. This is another brokering situation. Of course, if you're an administrator, you can search these logs directly through Athena, but we wanted to provide a mechanism for other staff from operations and security to log in using their company credentials to access this data. This is a screenshot of the Redash UI, which exposes a SQL interface to search the logs. We provide a few saved queries to get people started. Redash is an open source project. It interfaces with Athena using JDBC. It requires some knowledge of SQL, but it solves our immediate need. I don't have people asking me anymore, hey, can you tell me who did this action or who did that action, or how did this resource change over the last week? I can provide a self-service way for people to find that information for themselves. There's some limitations around query size with Redash, but we can help with that by putting a row limit in some of our saved queries and communicating that in our documentation. So I wanted to share this one. It's a very specific use case for us, but we've had great success with it. We created a tool we call Shadow Spot that allows development teams to opt in to using Spot instances for their autoscaling groups. Typically, this makes sense only for development environments, and that's all we're using it for today. So in order for a developer to opt in, all they had to do was add a tag to their existing autoscaling group. And we have a Lambda function that periodically scans all the autoscaling groups and swaps out on-demand for Spot instances that match the on-demand price. And when the Spot market price increases, the autoscaling group would replace the terminated Spot instances with on-demand instances seamlessly. This resulted in significant cost savings for us in a fairly turnkey way. So a bit about governance automation. We use a tool called Cloud Health Tech. It consumes our CloudTrail logs and provides some useful governance automation. We used to have home-rolled or manual processes around releasing EIPs and deleting unattached volumes. And after some time, excuse me, so we would release EIPs and delete unattached volumes after some time, but now Cloud Health Tech provides this, and they even have an approval process you can leverage to confirm the proposed actions are appropriate. Another thing I wanted to mention is that recently there was a new feature released for auto-scaling recently, which allows you to specify multiple instance types and purchase options within a single ASG. So you could potentially solve some of these same problems with the native AWS service now. So that's it for me for now. I'll be available after the talk if any of you guys want to talk about any of these subjects. Thanks for listening, and Cameron's going to wrap up.
All right, thank you, Brian.
Mm-hmm.
Okay, so we talked a lot about preventative controls and really how you can really stop things from happening. But you still want to think about the detective controls and the responsive controls. And so this is where there could be things that slip through the cracks. How do you make sure? And Brian touched on some of their detective controls around using config and inspecting CloudTrail and so forth. And so the idea here is you're going to want to establish telemetry and visibility. And so through those automations, you're going to be having high fidelity visibility into what's happening. And so taking those log sources, whether it's VPC flow logs, CloudWatch logs, CloudTrail, other services like GuardDuty, for example, being able to detect those events. So when something happens that's anomalous or for some reason it's outside your guardrails, it may not be something that's malicious. It could just be something that happened inadvertently. You want to go ahead and at least alert on that. So at a minimum, you want to be able to capture that type of activity. As time goes on, you'll find as you get more sophisticated, you'll be able to actually automate remediation of those types of things. And so that's a kind of something that you'll want to look at as you evolve your practices and start to get more sophisticated on the detection and responsive sides. So in summary, and kind of wrapping up, really what we'd like you to think about is as a kind of call to action is think about how you can go out in your environments and working with your teams and start out, regardless of where you are today, you want to move down that kind of approach of introducing more automation, less humans involved in that process. Typically, you're going to start out here in the early stages. You're probably very manual. You're probably hopefully following least privilege approach, but minimal automation. But then as you kind of move on, you're going to start introducing additional automation. And so think about where you can, if you're not using federation, move to federation. Start to move to infrastructure as code, whatever your flavor of choice is, if it's CloudFormation or something else. And then you can start to then introduce those governance checks like Brian talked about. And then ultimately, you're going to continue to evolve. You can think about enhancing that automation lifecycle, have those feedback loops, be able to have that kind of agile process where you're continuing to iterate and improve on that. So in summary, think about this in terms of this action plan. Implement guardrails, not gates, right? You don't want to have blockers. You want to build the guardrails and then let the developers and builders build inside of those. Start with least privilege and iterate from there. Embrace governance as code, and think about that brokering pattern where you want to have some proxy actions that are out there that may be high blast radius. Incorporate training, so you shouldn't have training be a replacement for representing these things in code somewhere, but you should have your policy awareness and communicate it out into the field. And then finally, policy is a verb, not a noun, right? It's going to be iterative. It's going to change and adapt over time. So that wraps up the session today. These slides and video will be available afterwards. I would say we'd love to see you at the party tonight. Hope you guys are going to go out and having a good week. And I think there's a few resources here. Brian talked about these, and these will be available. Should mention a couple of sessions. So it's late in the week, but we do have a few sessions here. There's mastering identity at every layer of the cake tomorrow. You've got a couple of DevSecOps and deployment sessions as well that you may want to check out. And then the resources, finally. So the blog posts, some of the tools that Brian mentioned as well. So with that, we'd appreciate it if you could take time to fill out your evaluations, and thank you again for attending today. Enjoy the party.